Hello and a very warm welcome. I'll show you step by step how you commission a STOBER system via PROFInet using the PROFIdrive profile. To help you follow the individual steps easily, I'm working with an exemplary system environment. A STOBER drive controller from the SC6 series, a Siemens S7-1500 controller, and the corresponding commissioning software. Commissioning takes place in three main steps. First, in the DriveControlSuite. Here, I configure the drive controller and then transfer the configuration. Second, in the TIA portal. I map the real PROFInet network, configure the participants, parameterize the drive control, and then transfer everything to the controller. Third, to finish, I'll use the TIA portal control panel to have the motor positioned. For the control, I've chosen a technology object of the positioning axis type. This means I'm controlling a position-controlled axis in application class 4 and using standard Telegram 5. Just for your information, in this video, I'll only cover settings that are actually required. Anything I don't mention, I'll leave at the default settings. Let's get started. In the first step, we create a new project in the DriveControlSuite and configure both the drive controller and the axis. To do this, I first start the DriveControlSuite. On the Start screen, I click on Create New Project. In the Drive Controller tab, I select the appropriate hardware. The SC6 series, the device type SC6A062, and the PROFInet firmware version. Moving on to the device control. Here, I configure the basic control of the controller. Under device control, I select PROFIdrive. And for the process data, I choose PROFInet in each case. Now I click on Axis A. Under Application, I specify that Axis A should also be operated with PROFIdrive. In the Motor tab, I select the motor type, EC401. Even though we aren't using Axis B in our example, it still must be configured correctly to avoid any possible faults. In the Application tab, I therefore also select PROFIdrive. In the Motor tab, I have to select the Lean Motor 401 here. Finally, I confirm the entire configuration by clicking OK. And now the DriveControlSuite creates the drive controller in the project tree. Let's continue with the axis-specific settings. I select the relevant drive controller in the project tree and click on Axis 1 in the Wizard section of the project menu. The power supply must be configured as we are operating the drive controller at 230 volts. In the Wizard, I select the Power Supply tab and enter for the undervoltage limit. 180 volts as well as 230 volts for the mains voltage. The encoder settings need to be adjusted because the motor has an encoder for one cable solution. To do this, I select the encoder X4 Wizard and choose one cable solution for the X4 function. Now I come to the limits, which I have to set according to my specific application. In the Axis Model Wizard, under Limits, Speed and Acceleration, I select 18,000 degrees per second for I10. For I11, I select 360,000 degrees per second squared. For the quick stop deceleration, I select the same value as for the acceleration. And for the jerk, I select 7.2 million degrees per second cubed. Next, I will define the reference speed. It is the reference value for the set point and actual speeds to ensure the application functions correctly. In the PROFIdrive application wizard, under additional functions in the drive data, I have the reference speed here and I set it to 3000 RPM. Now just transfer the configuration, save it and restart the drive controller. I click on Online Connection in the project menu and select the drive controller. I select the module, I select the corresponding drive controller, and I want to send my data to the controller. In the Online tab, I click on Establish Online Connection. The configuration is being transferred to the drive controller. As soon as the transfer is successfully completed, the window for saving values pops up automatically. Click on Start Action and the configuration will be saved non-volatilely on the drive controller. Afterwards, I can close this window. Now just restart the drive controller. To do this, I go to the Restart function in the online window and also select Start Action here. The drive controller is restarting. What did I just show you? I created a new project, selected the drive controller SC6 A062 with the firmware for Profinet and set the control to PROFIdrive via Profinet. After that, I configured axis A with the motor EC401. Axis B I set to PROFIdrive with the lean motor, even though it is not being used. Next, I set the power supply to 230 volts, activated the one cable solution option for the encoder, and limited speed, acceleration, jerk, and quick stop deceleration to suit the application. I set the reference speed to 3000 RPM. Then I transferred the configuration to the drive controller, saved the values, and restarted the controller. Now we'll continue with the TIA portal. In the second step, I'll create a new project in the TIA portal and configure both the controller and the drive controller. To do this, I'll start the TIA portal and select Create New Project. I'll give it the name Project 1 and click on Create. Now my project is being created. The project has now been created and I'll switch directly to the project view. First, the general station description file must be installed. To do this, I'll select in the menu bar Options, Manage General Station Description Files. Under Source Path, I'll select the path where I have stored the GSD file from STOBER. The GSD file is now displayed in the Content of Imported Path area. I can select this and install it. I get a message saying that the GSD file is already installed. I can make the window disappear by clicking on Close. Now the hardware catalog is being updated. Now we'll continue with the hardware configuration. By double-clicking on Devices and Networks, I'll open the TIA network view. In the hardware catalog under Controllers, Cymatics 71500 CPU, I'll select my CPU. I have to pay attention to the versioning of the CPU and can set it here. Then I'll drag the CPU into my network view using drag and drop. We'll now come to the drive controller. The drive controller is located further down in the hardware catalog. To do this, I'll go to Other Field Devices, Profinet I/O, Drives, STOBER Drive Technology, STOBER Drive Technology, Generation 6 Drive Controllers, and select the SI6 SC6 double axis controller with PD3. I drag and drop this into the network view as well. To enable communication between the devices, I establish a logical connection between the controller and the drive controller. Since I want to implement the control in application class 4 and Telegram 5, I have to interconnect the ports of all participants. For this, I switch to the topology view and select the port to be interconnected and drag it with the mouse button pressed to the partner port. Moving on with the Telegram, double-click on the drive controller and first we select the PROFIdrive module at slot 1 as well as at slot 2. As a submodule, we have selected Telegram 5 for application class 4 specifically for use in this context. Again for both modules. Next is setting the drive controller to isochronous mode. To do this, I click on the drive controller and select isochronous mode in the inspector window. I activate the isochronous operation and have to activate each module separately further down. Then the current times are taken from the GSD file. Moving on with the technology object. In the project navigation under PLC, I select Technology Objects and double-click Add New Object. The Add New Object window opens. I select the Positioning Axis Technology Object and confirm with OK. The new technology object is created and placed in the Technology Objects folder. The configuration window of the technology object opens. For the control, in the next step, I have to assign the MC servo organization block to the Telegram submodule for the calculation of the position controller. For this, I switch to the device view, mark the standard Telegram, switch to the I/O addresses in the inspector window, and select the MC servo OB91. For input as well as for output addresses, of course I have to do the same for both. Here too the MC servo in both places. Now I'll take care of the technology object. For this, I'll switch to the configuration window of the technology object. I won't assign a name, as I'm satisfied with the default designation. Next, I'll switch to the hardware interface section. For the drive, I'll click on the three dots and choose from the menu the previously configured STOBER drive controller, Module 1. In the encoder section, I have to set the encoder type to cyclic absolute, since we're using an absolute encoder. As I can see, Telegram 5 is automatically selected. My reference speed is 3000 RPM, just like in the DriveControlSuite. The maximum speed is 3000 RPM. And I have to set the reference torque to 7.5 Newton meters according to our motor. In the encoder data exchange, I'll select automatic transfer of encoder values at runtime online. I can simply confirm the message with OK. Moving on to the extended parameters. In the emergency stop section, I'll enter 10,000 mm per second squared for the emergency stop deceleration. In the dynamic limit section, I'll choose 500 mm per second for the maximum velocity. In the maximum acceleration section, I'll choose 10,000 mm per second squared, and for the maximum deceleration, I'll also choose 10,000 millimeters per second squared, and I'll limit the jerk to 200 millimeters per second cubed. Since my controller is in the lower performance range, I have to set the bus cycle time and the application time to 2 milliseconds. To do this, I'll go back to the TIA network view and select the CPU. Under Profinet Interface Advanced Options Real-Time Settings, I'll find the I/O communication and can set the send clock to 2 milliseconds here. Next, I'll go to the project navigation under Program Blocks to the MC Servo. Here I'll right-click and open the properties. Under Synchronous to the bus, I have to set the factor to 1 so that the application cycle is also set to 2 milliseconds. I'll confirm all of this with OK. Now just quickly transfer the configuration to the controller. To do this, I first select the controller in the project navigation. Then I select Online and Extended Download to Device in the menu bar. A new window opens up. I'll set the PGPC interface here. I'll set the connection to the controller here and which slot I'm plugged into. I select the controller, the CPU, and then click on Load. Then I'll just go ahead and say Accept All, and then select Load. I'll also set the module to restart after the loading process. What did I just show you? I created a new project in the TIA portal. After that, I installed the GSD file from STOBER and added the S7 1500 controller and the SC6 drive controller to the network view. I interconnected the ports, configured the Telegram with PROFIdrive modules, and activated isochronous mode. Then I added a positioning access technology object, assigned MC Servo as the organization block, and parameterized all basic and advanced settings, such as speed, acceleration, jerk, and emergency stop deceleration. Finally, I transferred the configuration to the controller and successfully completed the loading process. Now we'll continue with the control panel and the motion demonstration. To conclude, I'd like to show you that something is actually moving and that the settings shown lead to a result. To do this, I'll first start with the online connection. I'll select the controller in the project tree and select Go Online in the menu bar. For the motion demonstration, I've decided to use the Axis Control Panel. The Axis Control Panel of the Positioning Axis Technology object is a central tool for testing, moving, referencing, and viewing the status of an axis. This control panel is part of the technology object and is primarily used for commissioning and diagnostics. In the project tree, under Technology Objects Positioning Axis, I'll open the Axis Control Panel by double-clicking on Commissioning. By clicking on Activate, I'll take over master control on the Axis Control Panel. I can confirm the warning regarding life and limb with Yes. With a click on Enable, I'll enable the axis. First, I'll select the operating mode. Set actual position, as I want to show you absolute positioning. By clicking on Start, the position of 0 millimeters is adopted as the actual position. Now under operating mode, I can switch to absolute positioning. For the target position, I'll select 100 millimeters, and for the speed, 10 millimeters per second. With a click on the double arrow, the axis begins to move and stops at 100 millimeters. Now I'll select the target position of 50 millimeters. And by simply clicking the double arrow button, the axis moves backward to 50 millimeters. Next, I'll select 100 millimeters as the target position again, and I'll set the speed to 100 millimeters per second. By clicking on the double arrow, the axis moves to 100 millimeters, but faster this time. Now just back to the home position. For that, I'll select the position of 0 millimeters and click the double arrow. And here too, the axis stops at the actual position of 0 millimeters. I've now reached the end, and I hope I was able to show you how easily the STOBER system can be integrated into the Siemens world using PROFIdrive. Thanks for joining us, and see you next time.